Good afternoon, everyone. My name's Dirk Kley. I'm a Senior Technology Research Fellow at the National Security College. Today, we're going to be holding a webinar on strengthening Australia's security through advanced biomanufacturing. And welcome to everyone in the room today. I'm from the National Security College. I'm a national security practitioner. We also have two real industry experts joining us today. So we have Rob, who's the Director of the Advanced Engineering Biology Platform at the CSIRO, and we have Michele Stansfield, who's the co-founder and CEO of Cauldron Firm. So welcome to both of you.
Thanks, Dirk. Good to be here.
Great. So we're going to split the session up into basically three bits. We have the NSC has a new paper coming out on advanced biomanufacturing policy options in this country. It's going to be published today, and I think the live link is going to come up shortly in the chat. I'm going to give a bit of a spiel about that for 5 or 6 minutes, and then I'm going to ask questions of Michele and Rob, who are the real industry experts here. And then the final 25 minutes, we're going to devote to questions and answers. So if you have any questions that you'd like to ask Michele, Rob, or myself, please feel free to do so. We'll try and get to as many as possible. And we're going to try and keep it to a tight hour rather than an hour and a half, because for many people, an hour is all they can spare in their workday. So let's start with the paper itself. And this is designed to try and answer the question, why is advanced biomanufacturing good for Australia's national interest, but also our national security? What we should do about it and why we actually have a hope of developing an industry here. So by way of background, I'm a long time, China watcher, national security watcher. I'm actually not from the biotechnology sector like the other two people on this call. And I came back to Australia after, doing a lot of technology work on China. And I started to look around the policy landscape in Australia, and I got to, sit through a lot of senior discussions on what technologies we should look at. And I found that, I thought biotechnology was probably undercovered a little bit. You can see the papers just come up in its chat. And so I sort of got into it, and it became clear to me very quickly that amongst the critical and emerging technologies that Australia is interested in, this is one of our best, in my opinion, perhaps our very best chance of actually creating an industry and also dealing with some of the national security challenges that we face in this country. And so those challenges, I've written them down here. As I see them, we're in a world that is far less reliable in terms of supply of goods. It could be conflict, it could be a COVID-style disruption, it could be climate change, it could be some other unimaginable thing, but they're happening at a much greater rate than they were even 5 years ago. And so the advantage of biomanufacturing is that, for those of you that don't know the technology, is it's highly adaptable. You can use one piece of infrastructure and with relatively similar inputs can often change the output relatively simply. There's some things that depend on there, but you're looking at a technology that is adaptable, and in a time of need, you can change what you want. And often you're using locally sourced feedstocks, which is a big advantage over a lot of the other manufacturing technologies out there. Second, it's green, and later on I'll get the scientist in the room, Rob, to speak about this. It's replacing, if we get it right, a lot of highly polluting products. And then thirdly, it's a potential source of export. So Australia faces a real challenge that our major exports, your iron ores, your coals, your gases, those industries are entering structural decline. And so what we export today will be very different to what we're going to export in 10 years. And we're going to need to work a lot harder to develop an export industry in this country than we've had to do so previously. So that's sort of, why this is a good idea, why we're looking for something, to fill some security challenges. Well, then you go, okay, well, that's great. Lots of countries are looking at industrial policy now. A lot of countries are looking at biomanufacturing. Why does Australia have any hope in hell of actually doing this? And there's a few things. I mean, the first thing I'd point out is, one, we actually have world-leading companies producing product today, and there are very few critical and emerging technologies where we have Australian companies right now manufacturing and selling products somewhere in the world. We have a number of them. We have one of them online today, but we have others as well. Your Samsara Ecos that does plastics. got Vow Foods in Sydney, you've got Hygiene as well, and others that are currently selling product right now. We have world-leading companies here. The second point is we have a feedstock advantage in that, we have access to high-level sugar, we have biomass and an agricultural system that collects it better than just about anyone. We have advanced agricultural manufacturing already, so we have some of the skill sets in place. And we already export a lot of agricultural products, and so it's something that we can build upon, like with this new industry, to be really successful, I think. And there's probably a point in this because we are so expensive generally as a manufacturer. Any technology that's likely to be centralized globally, for example, mineral refining, for example, you end up with economies of scale in one location. Here, you're probably going to need to be closer to the feedstocks, and that means you don't have centralized manufacturing, which means Australia's cost base is not such a prohibition as it is for other technologies. And so we actually have a situation here where we have advantages where in almost every other manufacturing technology we have disadvantages. All right, so that's the background. What are we trying to solve? Why does Australia have a hope in hell of doing this? But then we need to get to, and if you read the paper, of course, you have to make suggestions. It's not just nice to admire the technology. You actually have to come up with some solutions. And I mean, the biggest one is really scale up facilities. If you are a startup that has created some new product that you might want to grow in a large bioreactor, you tend to need to run a test run that's bigger than your lab, but maybe smaller than a full commercial run, somewhere in the middle. And it's just very hard to get access to that. It's very hard to find it at a cost point that startups can do. And this means that they just delay and delay and delay and delay and delay. And they also end up looking around the world to try and find facilities where they can do this. And if you do some of the startup somewhere else, some of the scale up somewhere else, you often end up just moving there because it's easier to do it there than it is to, come back and then build a manufacturing base out of where we are now. So that's sort of the first point that I want to make. And I've got the points here, and I want to be clear. The government, I think, is doing a job that is better than was 5 years ago. We've got these days, you've got the NCRIS, the NCRES, which is for research infrastructure. You have the Industry Growth Program, which Michele's company has just won a grant on. We have the National Reconstruction Fund, which has not yet released a grant, but it could potentially be a source for building infrastructure. And we have the Future Made in Australia, which was announced by the government relatively recently, which could be a big pot of money for manufacturing in this country. So we have money either just starting to come out or potentially coming out the chute quickly. Unfortunately, for this particular technology, I think none of those four actually fit the right space. Generally in the scale-up space, we're probably looking at something that's not going to make money in the short term. You're looking at companies that are small, that have a high fail rate. And you look at anywhere around the world where you have these scale-up facilities, they tend to be government set up, or at least government funded initially, not always government set up. And then you need ongoing funding for the maintenance and upkeep of this, because the cost recovery from the companies just isn't enough to fund the entirety of the facility. And so if you're looking at an NRF, which is designed to get things which are going to allow you to have to pay it back in a short period of time, something that's going to generate positive revenue, that may actually not be the case. Now, everyone knows you don't want to just build infrastructures and white elephants, but I think evidence over the past 30 or 40 years shows that if you want to build an industry from scratch that's, deep technology, you do need government input on some of the infrastructure. It just doesn't happen by itself. And so government's come a long way, but on this, there's a real gap. The second part in this, we've suggested funding for feedstock research. I mean, feedstocks are going to end up being one of the decisive factors in this particular technology. Collecting them, finding different types of feedstocks. So when you're building things at huge scale, we can actually, get enough of it to where we need to do. The third and fourth points are sort of about the coordination. Now, we're not the first, me and the co-authors of this report are not the first to make these suggestions, but something that is like a joint industry government body, akin to, say, the US Biomade, where industry and government work together to work out where you're going to build scale-up facilities, structures around that, which should allow other companies to come in and move in relatively easily, coordinating that with research. and then also looking at offtake agreements and looking at feedstock supplies. So you have a coordinated look around each one of these facilities that's going up. Now, there are some facilities already going up in Australia, and we could all definitely go around the ones that are already there, but a much more coordinated set of funding and probably a much bigger level of funding. In terms of the industrial policy in this country, notwithstanding Michelle's company's latest grant, advanced biomanufacturing has actually been relatively small. All right, that's about an 8-minute spiel. I promised 5 or 6. I went a little bit over. I'm going to sort of turn to Michele and Rob now and, do question and answers. And I deliberately avoided doing the technical explanation of what biomanufacturing is because we have real experts in the room. So Michele, why don't I turn to you first? And you give us an explanation of what biomanufacturing is and maybe an explanation of how a company like Cauldron, which does biomanufacturing, operates.
I was going to say, I just looked at the participants list, and I dare say most people in that list know what biomanufacturing is, but ultimately we're harnessing the power of biology to create new products. So new products or similar or bioidentical products. So, instead of using petrochemicals or agriculture to create products, we use biology. We could do that through precision fermentation, which Cauldron specializes in, through molecular farming using plants, and then, of course, biocatalytic sort of technologies as well. So I guess what we're looking at now is it's not a new technology. Biomanufacturing is not new technology. It's how vaccines are made. It's how insulin's made. What we really now are looking to do now is use that technology to create more mainstream, lower cost products. That's where we have to change that paradigm to be able to feed an expanding population and protect against climate.
And it's a direct competition against a lot of fossil fuel products, not just fuels, but all the derived products, which most people on this call know. But for anyone who doesn't, your entire industrial system runs basically on petrochemicals. If we just call it as honestly as it is, and getting that price point really means with competing at a price point that fossil fuels actually do. That's essentially the challenge here, particularly for the non-food stuff. Would that be a correct characterization of that challenge, Michele?
Absolutely. These industries won't grow on the back of green premiums. Like, everyone knows that. We've tried for the last 10 years on trying to sell this technologies on green premiums. It just does not cut it. So what we need to be able to do is bring costs down to a space where it competes with conventional technologies or manufacturing.
And that's hard to do. This is nothing we can do to change this, but of course, fossil fuels globally are actually highly subsidized as well. But that's a discussion for another day. But we're at a point. I think you've nailed it on the head there. That it's a wide range of products, and this is why this is such transformational technology in ways that others aren't, because it's not just fuel. It's cosmetics. It's acids. It's food dyes, the dyes that go into our clothes, lubricants and chemicals that can be used in warfare, things that can go into munitions. It's a long list. And Michele, could you just also speak about, how easy is the adaptability between one product and another? If you're in a situation where you're looking at a, conflict or some sort of disruption, how easy is it to change what you're making in the bioreactor or whatever you're using for this?
I wouldn't say that they're easily adaptable. However, they're much more adaptable than having a petrochemical plant versus a food plant. I think we've looked at potentially to retrofit a fuel plant to become a food plant. We're talking in tens of millions of dollars, not hundreds or billions of dollars. So that's what you're really looking. So if you're in a space of conflict, and we'll get into the US push later, and that's what they're really looking at, having these multi-purpose facilities for the times of conflict. So one moment they're doing fuel, next thing they're doing proteins. So it's an interesting. The adaptability is there. It is there. But it's not as simple as people think. But it's much better than incumbents.
Better than incumbents, but still, it's going to be work. Like if we do it. All right, Rob. Can I ask you to maybe add just a little bit, sort of, on the environmental benefits? Why is this technology, say, more green than the fossil fuel incumbents that we have, or the agricultural incumbents, if we're talking agricultural products?
Yeah, thanks, Dirk. Firstly, just to say as well, I think it's great that you've as you explained, you've come from kind of outside of the synthetic biology biomanufacturing industry, and as an external person recognise the great potential that it's got. And so, yeah, very grateful that you've made this report, and dedicating all this thought into helping things move along. I think you talked about a lot before about kind of what is biomanufacturing, and I think you almost said it's kind of everything that's manufactured that's not using fossil. Also, we're clearly in an environmental crisis at the moment, one that's building and getting more serious all the time. And there is this imperative, I think, that we move away from a fossil-based economy to something else. And if it's not going to be old carbon that's been locked in the ground for millions of years, then it's got to be new carbon, and that's got to come from somewhere. And so biomass and plants is a good way to do that. It's a good source of carbon. So I think, yeah, we've got to do everything that we can to dismantle, I suppose, this fossil-based economy that you talked about, and move towards a bio-based one, because that's the only way we're going to make a significant dent in carbon emissions and what's driving climate change at the moment. So yeah, so we've just got to keep plugging away and work as hard as we can, like Michele said, to get the cost down, to diversify the products that we can make, and try to mature biomanufacturing as a sector, as an industry, to the point that fossil oil is at the moment. And that's very hard to do at the moment as well, because I think, like you said as well, like the fossil companies currently get a lot of subsidies. But also the fossil industry was largely a national industry when it started 50, 60, 70 years ago. It was governments that set up British Petroleum, Total, and so on. There were state-owned agencies. And so currently we're not competing on a level playing field cost-wise when you're trying to bring in new technologies, new processes, and trying to scale up to the level that the fossil industry is at. It's just really, really hard to do. So it's not really a fair competition at the moment, but we have to keep plugging away and trying, because it's imperative for climate that we do that.
No, and there's a really I think key point to add here as well for any policymakers that are watching. This really deals with the hard to abate sectors. So obviously we've got solar panels now, and electricity is being used to do a lot in terms of like just passenger vehicles and just general electrical emissions for your home and for your business or whatever. The chemicals and stuff that we're talking about, there's no real easy solutions on the horizon at the moment. Like, there is this one, but there's nothing easy. There's no obvious alternatives, and this strikes me as a really, like, it's the game. And for anyone who doesn't know, I mean, I'm a China watcher by trade, and they are going to spend tens of billions, maybe hundreds of billions coming down the track on this technology, because they see the advantages. They know, and they are at the center of the global fossil fuel industry, that this has to change. And the US is also going to spend a huge amount as well. They've got a number of projects that billions of dollars at the moment, but I think once they ramp everything up across US Biomade, it's going to be tens of billions of dollars just in straight government funding. So this change will probably come either way. We don't know the exact speed as to products getting knocked down, but it is going to come, and we kind of have a choice. If we just let others do it, and that's great, more power to you. But if that happens, we lose the exports we currently have, and we don't find something new. And so from where I sit, it's really important from that point. All right, we've laid out the case for the actual technology. Let's go. So I'm going to ask Michele one question first, but of course, Rob, you can jump in. I mean, how would you describe the state of the industry, like just in Australia and globally, in terms of, how far away are we from getting price competitive products? I mean, there are actually some that are already price competitive, to be honest, but in general, like how many years do we think we are from getting price competitive products across like a wide range of industries? And how is the sort of the state of the industry in Australia as well?
I think first and foremost, I think when I think of market, a lot of people concerned about the market. We're seeing a huge appetite from incumbents. So we're talking about the Nestle's of this world, or potentially Nestle's being a form of person, not a company itself. Large ingredients companies or large off-takers. We're seeing that at the moment, they really want fats to stretch their supply chain. Like they're really looking at supply chain security. So talking about stretching, for example, dairy fats being able to make 6 billion pieces of cheese instead of 4 billion pieces of cheese, or egg whites in baked goods and things like that. So we're seeing a market develop not as consumer products, but in these ingredients. So I think the market is there. It's just all about costs. Ultimately, it's about cost. And how far are we off from cost? We've got a couple of companies in Australia who are already at cost for their products, which is exciting for them. But ultimately, when we're talking about milk as a product, or milk proteins, I would say we're halfway there when it comes to the improvements in cost. And I would say, I think we'll have things in market or going into the large food processors within 2 years at competitive costs. That's what we look like, 2 to 5 year horizon. Ultimately, it has to, because if you look at the avian influenza and the staph staphylococcus, salmonella that's going through the egg chain at the moment. We're at a precipice here, and we need to really push these products through. So that's what Cauldron does. We're about pushing down the cost of goods.
Yeah, and I should point out that I'm currently in Japan, but I've been in Northeast Asia for the last week, and inflation on food has been a big issue in this part of the world because there's been unseasonably high temperatures and higher rain than expected, and so food production isn't where it was once. And I think most people know this, but it's worth repeating. We're in a world where, like, for many years, food production just went up and up and up and up, like no problem. It was kind of okay. That's changed in the last 5 or 6 years. And it's like, once, of course, reliability, but also overall production at points has not been as high as it once was. And so it might be the case that prices that you're trying to beat actually go up. Agriculture, if you're looking at an agricultural product, you might end up meeting somewhere halfway between. And so I think we also have to envisage a world for the agricultural side. I think where this will become pressing sooner, because it's like food in the mouths. Whereas like for other stuff that uses fossil fuels, it's causing damage, but it's not something that you can't, like, you fly on a plane, for example, you don't, there's nothing stopping you from doing that still. But if you're at the point where like eating becomes very expensive, it creates a different kind of dynamic on that. Now, one more question for you, Michelle, on this, like, any comments you want to make on the state of industry in Australia as well, where we're at, say, with respect to the rest of the world?
I would say that we are, as a consortia, we're doing the usual thing, like knuckling down and working hard. But ultimately, if you look at, I'd call us an emerging industry, and I would say that the US is potentially more mature, in that they have Biomade, so they have an industry group, and they have the Precision Fermentation Alliance and things like that really are bringing people together and allowing them to mature at a greater rate. And for that, because they have these consortia, they're getting government funding in. I'd say we're still quite disparate. Like in CSIRO gets funding, QUT gets funding, Cauldron gets funding. There's no particular cohesive push. Europe's just an interesting one altogether. They're quite mature when it comes to biomanufacturing through vaccines and all chemicals, but when it comes to food, they have issues with regulatory. So I'd say with the mainstream product, Europe is probably behind the rest of the world because they just don't have the regulatory framework to allow that. And I guess that's the thing, the regulatory framework in Australia is also we're on the up, and we're seeing the OGTR have obviously given us our first license to ferment outside. And also FSANZ has got, everyone's working really hard with FSANZ to get a really good market license framework.
So just on the regulation front, so this wasn't the focus of this paper, but next month or the month after, we have another paper coming down the track, which is about gene regulation in this country as well. So we're aware that the regulation component is important. I think, to your point, that the OGTR is actually working pretty hard to try and make it a more friendly environment, but it's complicated. And also I think there's a staffing issue, and just we haven't seen a lot more products coming into this realm than was a few years ago. So that's really helpful. I can see questions coming on. Thank you. Rob, over to you. Feedstock. So I know I said we've got advantages in feedstocks, but what are the feedstocks we're sort of looking at here, and what kind of needs to happen for us to actually take advantage of them in your mind?
Yeah, thanks, Dirk. Yeah, I think you talked a lot about biomass and agricultural-based feedstocks, which is certainly an advantage for Australia. We've got, like you said, a world-class agriculture industry, whether it's the sugar industry or other types of agriculture that we can use. I think a lot of it is going to be about matching the feedstock to the product as well. So I think things like the sugar industry, it's already a food product. It aligns really nicely with generating food ingredients that way as well. I think obviously you have to consider volumes. You talked about shipping and movement of biomass around and the need for local manufacture, but also if you're thinking on a big scale around things like climate change, is how much aviation fuel can we really replace using agricultural feedstocks and the feasibility of that. So clearly it's not the only solution. We need to have societal changes around that as well. But the fossil industry is so vast that it's going to take a long time to wind that down and wind other things up. At which point, like you said, I think as well that local manufacturing, the production of materials and chemicals close to where they're needed is going to become important. But that's also where we think we have to be a little bit more broad in our thinking about what feedstocks can be and how you can use them. Agricultural feedstocks still are fairly costly, depending if it's highly fibrous to break down to sugar to make into products. And one way to do that potentially is to gasify that biomass. So you generate some kind of syngas, and there's microorganisms that can grow on gas and make products as well. That also takes quite complex and variable biomass types into a more streamlined or more homogeneous feedstock that can be used. So I think we've got to be quite open to lots of different feedstocks. And I think if we start thinking about gasification, then we start thinking about actual transitions from fossil into other things as well, where you can take things like methane, which can be generated by anaerobic digestion from food waste, for example, but also is coming out of the ground as fossil methane. So there's an opportunity to start building processes, I think, on different gas sources. And if ideally it went well, then we could start to see some of the fossil companies and the ones based in Australia who are generating all that huge value for the country and really important, that they could, over the decades to come, start to transition into different sources of gas as well. So I think a big question is, what role is there for the big fossil companies globally, and particularly the big gas companies in Australia, for them to participate willingly in this transition and start to catalyze things. So not immediately necessarily, but over the next 5, 10, 15, 20 years as the economy changes. And so I think we need to consider all feedstocks because it's an issue about scale cost.
Can I just for anyone who's not a scientist, including me, on there, when we talk about the using the big gas producers in this country, you're talking about them as a source of CO2 or as a source of methane that can then they can use to be feed to grow microbes as well. Is that the sort of
both really? Again, that's the power of biology, is that you can find a microbe that pretty much eats anything if you look hard enough. And you talked about adaptability. Obviously, with synthetic biology, we can modify those organisms. So if you find one that can grow methane, or you can find one that grows on carbon dioxide and hydrogen, for example, they can be engineered to make products. And one of the most promising examples in Australia at the moment is what LanzaTech are doing in the country as well. And obviously that's a gas fermentation process where they take, say, syngas from a steel mill or from some industrial process or from biomass gasification and turns that into fuels and chemicals.
Yeah. So and once again, I take Michelle's point before, but if you're looking just at chemicals, the changeover sometimes a little bit easier than if you're going from, say, food straight to chemical to like a fuel. You can potentially change the microbe and come up with a different outcome more quickly than you would be able to if you're going from, say, food grade to fuel grade. I'm just checking that that's right. Sorry, I just want to make sure.
I think that's more of a production problem. This is Michelle, your thing really, but yeah, you're not going to suddenly switch from making aviation fuel to making a food ingredient, because the requirements around food safety and that kind of thing, and the scale and all those things are different. So one's very much an industrial plant, one's very much what looks like a regular food plant.
Okay, perfect. So we've got two, like we've set this up. One more question. I can see a couple have come in. One or two have come directly to me as well, but that's okay. What happens if we miss the opportunity? So let's say we don't set up the industry here, but it still happens. It still happens in the US. It happens in China. It happens in Singapore. You know, we get all these great products anyway. What's the cost to Australia? Michelle, why don't you go first? And I'll add this. Oh, you go, Michelle. You go.
Yes. I would be a little bit provocative there, saying, you know, we're going to get these products anyway, but for us to potentially be importing genetically protein from China that's come from a genetically modified organism, there may be, I think it's an assumption we can't make that we're going to have access to these products or these fuels or anything coming out of other regions. Only someone have done thousands of import permits over my life. That's an assumption we can't make. But ultimately, we have some amazing tech and tech companies coming out of Australia. You know, you've mentioned some of them. They'll go elsewhere. Like this industry will happen. The question is will it happen in Australia? And ultimately, there's a lot of money coming out of the US. You're talking about how much China's investing. These companies will go overseas, and we're already seeing that. We're already seeing that happening. Like Val's creating a manufacturing, or will they create some product in Singapore, I believe, and other companies doing the same sort of thing. Like people are having to go elsewhere because we just don't have the capability here. And that's ultimately is like Capital Brief article the other day. The headline was Cauldron sets its eyes on the US because of incentives. That is ultimately what will happen if we can't support this. Regulatory wise, we can't support it with scale up facilities, and ultimately access to capital. These things cost a lot of money to build.
Before I allow Rob to jump in, I just wanted to say I in this job, go around and try and speak to as many companies as I can. And of course, you could do this in almost any industry, and they're thinking about relocation. Where are they going to go? Where are they going to get the best deal? That's normal and to be expected. And for anyone who doesn't know, like Samsara, a company that's come out of ANU, they do plastic eating enzymes. They've got 2 facilities in Australia, and their third one is planned to be built in Vietnam. They announced it just the other week. From where I sit, I obviously completely agree with you. Otherwise, I wouldn't have written this paper. But I would add that I think where we should look to have is, you know, serious manufacturing in Australia. But because of the nature of biomanufacturing, we might end up in a world where the headquarters stay here. Serious manufacturing happens here, but of course, eventually you'll see manufacturing in other places elsewhere. And I think that's okay, but we don't want the whole company to move elsewhere. I think that's something that worries me a lot. And when I speak to companies here, they're like, oh, we're going to, you know, they are seriously considering options in the US because of Biomade for one reason and others. So that's something that really worries me. And I just want to hammer home a couple of points. When it comes to research in this country, we have a lot of really good biologists. There aren't, once again, many other critical and emerging techs, maybe like quantum is one, but there's not that many others where we have such a deep batting order of experts across a wide range of one, you know, particular study of science. So I just, it would be a shame to miss out on that. All right, Rob, well, we've set up and given the leading question. I mean, do you have anything to say? You know, is there something else that we miss out on if we don't do this in this country here?
Yeah, I was just going to talk about companies, startups from this country potentially going overseas. But if we get it right, the opportunity is the flip. Really is where companies are already located overseas, maybe they're headquartered overseas, but they're looking to proliferate their technology. And I think that's what we'll see as the industry matures, because of the availability of feedstocks and the need to address markets in different areas. If you want to grow a startup in biomanufacturing into a global company, you're probably going to have presence in different parts of the world. And so that inward investment is also a very big opportunity for Australia if it gets it right. So I'm located up here in Brisbane, and the Queensland government have had their biofuture strategy for about 10 years almost now, and worked really hard with Trade Investment Queensland as well, for example, to really build those links and connections with companies. And many global companies, both big and small, have been through Queensland to have a look, largely based on the sugar industry here, I think, and the potential for feedstock. So we've got a good base there. And I think now that we're starting to see manufacturing plants being built around the world, it's important not to take the foot off the gas with those relationships and those interactions, and to have that patience. And I know it's hard, for governments as well, to keep going decade by decade. But I think we are coming out of this kind of lag period where we're starting to see plants getting built, and so the inward investment opportunity is really there. The other thing I was going to add as well, you talked about biomanufacturing is already established. I don't think if you take the broad view that it's biomanufacturing is anything that uses biology as either feedstock or in the processing, like in fermentation. The global chemical bio-based industry is $80 billion a year. At the moment, it's about 3% of the chemical industry, and it's growing at 10% per year, whereas the whole chemical industry is only growing at 1 or 2%. So it absolutely is happening around the world. And again, we want to start to see more of that happening here in Australia.
Well, you've now ignited my inner China watcher, because if 3% is 80 million, you're looking at the chemical industry is $1 trillion industry, which is big. There are very few $1 trillion industries out there which we have a hope of getting some bit of. What I would say is we're at a situation where China controls the chemical industry right now. And one of the things that hasn't been well studied is actually, where China is up to in doing the bio-based side of that. Yes, there's lots of places that show you where potential facilities are. I think China's actually a lot further ahead in the industrial biomanufacturing than we actually think. There are a lot of companies out there that are sort of doing scale-up stuff that isn't really getting covered anywhere else. And so it's kind of like now or never for us. And if we're thinking in terms of global reliability, if a country was going to be the one that's likely to impose sanctions on us or other like-minded countries, China's going to be the most likely of the industrial nations. So it just sort of sits me there that if we don't do it, the vulnerability point that Michele mentioned is really, really important. And the inward intention is also really important as well. And my sense is there's been a lot of companies that have looked at Australia as a potential investment destination. Okay, there's LanzaTech and there's a few others that have kind of come, but a lot of them have been a little bit hesitant because the industry doesn't have enough like steel in the ground in a way, and probably not enough scale-up facilities. So I think if we can get our domestic house in order, there's a lot to tap in there, would be my view. Anyway, it's time to switch over to questions. So if you have a question, just direct it to everyone in the front. I'm actually going to go to Justin first, because Justin's also a fellow non-scientist, so he tends to think of things in policy terms. As you say, Australian agriculture is very, very efficient. Is there any low-hanging fruit in terms of agricultural byproducts that are unexploited and useful for biomanufacturing? So what are the first feedstocks that we might use if we go past sugar? I think is essentially that question is, where are we going to get cheaper biomass than we would otherwise possible? So who wants to take that one first?
I'll set context, but Rob is definitely the person to comment on this. So we're talking about precision fermentation, like we're not talking about wine where you kind of squish some grapes together and put a bug in, it grows. We are the F1 of fermentation, and that's how we liken ourselves. So we can't use E10 fuel. We need to use F1 fuel for this. So most importantly for precision fermentation is we need a repeatable, robust, carbon-intensive feedstock. That's what we need. But reproducibility and repeatability is what we need. And that's the biggest challenge when it comes to feedstock, is that any other feedstock other than sugar needs to be consistent.
So
Okay,
consistency. And just for Justin on this one as well. So precision fermentation is one way, and I think like Michele's got a 25,000K facility and you're looking at a 500,000 litre facility that you're raising for right now, that's, going to be one really, really important part of the industry, but it's not the only one as well. So for where Michelle's company goes, it's the F1 fuel. For others, it's a bit different. You go, Rob, and then I'm also going to have my thoughts at the end.
Yeah, I mean, it's the classic question, isn't it, really, is matching the feedstock to the product. And there's been a lot of work over the last 20 or so years, especially in Australia, around different agricultural industries and different sectors and different areas around what biomass are they not utilizing or getting the most value for, whether that's the banana industry or other types of farming. It all then comes back to the question of volume. So there might be huge tons and tons of banana waste, but that's not convenient to make fuel from. And also if you've got this kind of regionally produced biomass, how can you make an economic process at a small scale? So I think that, this is something we've got very much in mind in our thinking as well. We want to make processes cheaper, more efficient, so that they can be operated at smaller scale. And so you can start to see this distributed manufacturing, where you can take a range of feedstocks or different feedstocks in different places and still break them down into something that's usable by microbes, whether that's gasification, as I said before, or you build in some robustness to your production strain that it can tolerate different inhibitors or whatever in the feedstocks, and then have these regional manufacturing hubs. And again, I'm thinking into the future here as well, but that adaptability as well, where you can start making different products in the regions that are going to use those products, is something to aim for. But yeah, there's no Justin, I don't think any kind of hidden big store of fantastic feedstock that nobody's looked at yet. I think pretty much everything has been thought about, but we just keep hitting against these fundamental challenges of scale and cost.
So that's thanks for the thumbs up, Justin. I'm going to add a couple of things in that, just to make clear, we're going to end up with a sort of, I think, a range, and the US biomade model is good because in certain places you go for like the F1, which is usually a nice sugar that's easy to deal with, and then you'll go somewhere else where you're dealing with bigger, less valuable molecules generally, and in that case, you're looking for feedstock that's cheap. And so you see a world now where they're trying to use gasification, or with like a company like Hygiene in Australia, where they're looking at having some sort of catalytic process, and you can feed a lot of different feedstocks into that. So there's no one. I know you want, like, I'll just say sugarcane, and that's probably where I think that's where we've got a scale-up facility going by QUT at the moment, but it's going to be a little bit more, I hate using this word, nuanced than that, that we're going to need different feedstock sources for different types of things, and hence why we need a number of different scale-up facilities. But as you say, like as Michelle was saying, on her, like sugar going into things that are like milk proteins, they are in the position where they'll be hopefully competitive with industry in a few years. So you have lots of different little things, but it's not just one particular feedstock for one thing, and each particular like chemical has that exact same question being asked across the board. So
but hydrogen is a great example though, Dirk, with Hygiene as well. If we can get cheaper green hydrogen at the right scale, that's a fantastic energy source for either using chemistry directly with carbon dioxide to make things like methanol, or doing that biologically. So again, there's microbes that will grow on hydrogen and CO2 and generate a whole range of products from that. So hydrogen has a role to play potentially as a feedstock component if we're going to be looking at, say, CO2 or carbon monoxide as the carbon source.
Yeah, so and they are one that I think, like Hygiene is one company here that is a real potential to do that. Okay, let's jump on to the we'll go to Robin first. His question, I think both of you probably know Robin, is a question about talent. I mean, do we have the talents? What are we missing? I know every time we meet together, we always talk about talent here, but Michelle, in your company, is there one thing that you'd probably want? I know you're likely to say tradies, but beyond tradies, tradies, and what are the skill sets that you're finding it hard to find, or has it even got better in the last year or two? Have you actually got better at finding the talent?
The hard one, because this talks about we have two different scales. Where we are at the moment with the pilot and demonstration facility, it is about scientists, and it is about in that context, in that scale up facility, it is still about scientists, or it's about chemical engineers. It's not necessarily strain developers or synthetic biologists. I think everyone just tries to throw synthetic biologists at this, but it's about people who can actually look at a process and execute a process, not necessarily do the strain. So there's a huge, I guess, fermentation scientists in our industry they're very, very hard to come by, which are usually chemical engineers or say microbiology degree. And then once we talk about potentially the full-scale plant, which we've got to push into far north Queensland at the moment, we've been purposeful in where we've selected to build these facilities, because we're talking about tradespeople, we're talking about operators, like facility operators, not scientists. So we're very deliberate in the way where we plan to build these facilities for access to the correct personnel. So we don't need scientists in far north Queensland. We need operators and food handlers and tradespeople. So
You'd
but
hope
I
there'd be
think
some transfer.
sorry.
Sorry, no.
No, so but that fermentation scientist, like not necessarily synthetic biologist, but that process development scientist, chemical engineer, is still bioprocessing engineer, and all credit to Ian and the team at QUT for putting that bioprocess masters together. That's exactly what we need to be doing it, but we need to be jamming people through.
So you need people to be coming out faster. This is going to sound like a very naive question. If you have someone that isn't an engineer or hasn't done like bioprocessing but has a biology background, is there a way to jam them through how quickly do you think you can get them through a program that might make them employable for a company like Cauldron?
Well, we've been doing that in our Orange facility for the last 12 years. We're finding people who have enough knowledge to train them up, and we've had to do internal development for that reason. I'm not an expert in education. I don't know if Ian wants to weigh in on this, but a microbiologist, someone who knows how the bug grows, I'm not really sure. I'm not sure if we're asking for external contributors, but I think Ian O'Hara and the team there would be the people to answer that. Okay. Or maybe Rob, you've come from there.
Yeah, well, I think you had it before, Michelle. I think the chemical engineering is key. Really, obviously, you need the microbiologists and synthetic biologists for making the organism in the first place and making it more productive. But really, for manufacturing, it's the chemical engineering that needs to come in. So it's good to see that QT Masters in Bioprocess Engineering coming through. I was going to say as well, you'd hope that, especially in the regions where you're building manufacturing, that there's transferable skills that are up there. So the gas fitters, the welders, operators, and so on. Maybe there's an opportunity for short periods of retraining that people can do to upskill, but readily transfer what they're doing. The thing I was going to mention, you mentioned Biomade a few times in the US. I think one of their plans is to try and build 10 pilot plants in 10 different states across the US, and the idea there is also for training, so that companies can come in and not only they're kind of demonstrating the process, but the operators are getting training as they're coming through on running equipment, and then the processors and the people then graduate out of those pilot plants into their own facilities. So that if that comes off, that'll be a very powerful mechanism in the US for training as well as maturing technology.
And we've just got a message from Ian as well. It's like, okay, it's great that we train these people, but we need to know that they're going to go into jobs, because that as you have your facility, and there's a few others around as well that are building manufacturing facilities, Samsara, Hygiene, and others like QUT as well. And they sort of say, well, it feels hard to get the process engineers, but up until now, there haven't been a whole bunch of like advanced biomanufacturing. Yes, there's been brewing and stuff like that, but advanced biomanufacturing, there hasn't been a lot of scale to it in Australia. And so it's kind of the classic chicken and egg, as you mentioned. But if Michelle, if you're successful getting a 500K facility, 500,000 litre facility up, well, then you will start to really need, I imagine, process engineers, at some point, relatively.
Just, yeah,
You
I'll just
you
add
going?
to what Rob was saying before, with the say the Greater Whitsundays region where we're looking at the moment, we're actually looking at micro credentialing, so reskilling, mining to dining. So there's a looking, we're kind of looking into ways that we can work on micro credentialing with the region, within the region as well. Incredible group up there, the economic development group, are really looking forward into this sort of stuff.
Yeah, and I think for everyone online probably has sort of picked this up already as well. One of the big advantages of this is that actually will go into areas that are likely to lose out from mining decline. It's one of the nice inherent inbuilt advantages of biomanufacturing, which wasn't a piece of this paper, but it's a nice additional advantage. All right, well, we have one other question here from Sion Lim. And what kind of funding is needed at each stage of development? So where you are now, Michele, I know you've just won a grant. There's the National Reconstruction Fund, which at some point will give someone some funding somewhere. I don't know where it's going to go, but and they're, I think, looking at debt. But where you are now and across the development stage that you've had, what if government's going to tip in funding? What's sort of the hierarchy of preferences for you?
Well, okay, so context, we're talking about the biofabs now, so we're talking about the 500,000 litre facilities. The 4.3 million from Albanese's government is going into the Orange facility, so the demonstration facility, so we can get more customers through. When it comes to how would you fund these first of a kind facilities, only freaking idiots do it with equity, which is what I have to do at the moment. Ultimately, you don't build factories with equity, but Cauldron is obviously having to draw on that at the moment, and that's sort of part of our Series B. But from here, what we are really working on with is, obviously grants or anything non-dilutive would be important. So the first facility, we're looking at equity, we're looking at grants from governments, and we're looking at government or government debt. So government debt providers, depending on the region, who they are will vary. And the second facility will most likely still be a grant with debt. And then as we build more and more facilities, it becomes less risky. We'll be really pushing into more debt. At the moment, we're looking at a venture debt or government debt. We want to get out of venture debt because ultimately it's easier for us to service like conventional loans and debt finance.
And am I reading between the lines here that at the moment conventional loans are hard to come by for the stage of development that you're in with your company?
Yeah, we have technical risk and market risk. So it's very hard for us to talk to the Commonwealth banks of the world, or HSBC have venture debt provisions. Some of them do have that, but really typical big fours and the big guys, it's just too risky.
Okay, so at the moment it's elsewhere. And so the sort of follow on from that is like government debt is not a bad option. Sort of an NRF model is not bad. Unfortunately, as I said, for where you are, that's good, but for the scale-up facility, that model I don't think will work quite well because scale-ups...
They have an economic mandate. They have to actually make money.
Yeah, that's the main problem. So anyone listening from government, I mean, there's just a gap between where industry growth program finishes and where NRF starts. That scale-up facilities are just absolutely not being met here. And from where I sit, this is one of like the easiest ways for us to build economic security out of all the like difficult ways that are in front of us. This is a difficult but the least difficult way, and the one that probably has a reasonably high chance of success. So if anyone else has any more questions, please come in and answer them now, because we're going to finish up very, very, very shortly. But I'm going to draw on you, Michele and Rob. Were there any final messages that you wanted to drive home before we finish up?
Rob,
why don't you go first, Michele?
Okay.
You go first. Sorry, Michele. I'll put you on the spot.
Again, this is a huge opportunity for Australia. We have great economic, geopolitical situation, great IP. We got feedstock, we got renewable energy. This is Australia's to lose. And unfortunately, at the moment, Australia is losing with the executive order in the US, the CHIPS Acts, the Inflation Reduction Act. They're in the right place to take all these companies from Australia. So we don't ever want that. Everyone's starting to go, you're turning into Team US, but no, I want the best for what's Cauldron, which is a company in Australia. But again, I need a company to be successful before I can stand behind a government. I'm not going to have an unsuccessful company because just to make our government look good. So there's a very fine balance that we're walking at the moment. We need to push through, and we need to quickly.
Rob?
Yeah, I just want to comment. I suppose for me, I'm just very heartened by the growth that we've seen in Australia, particularly on the tech side. We've now got a pretty mature ecosystem, given that probably 10 or more years we really didn't have an identifiable synthetic biology network or ecosystem. And in a relatively short space of time, we've got fantastic universities, we've got research coming through. We've got the facilities. We're starting to see companies like I think 16 companies in the last 2 years founding. So we've just got a really great foundation from which to build. And when you couple that with what's going on around the world, and we're starting to see plants getting built around the world and so on, we are in a great position. I think you mentioned in your report, we can still do a little bit more to come together with industry and to interface with government in an appropriate way. That will help as we go forward, but we've certainly got a fantastic foundation, I think. So I think the future does look bright. You just got to keep plugging away at it.
Well, I like that positive finish. I'm going to say somewhere maybe in between the two of you. Yes, like the industry is actually, I think, working together as much as an industry can when you have so many different stakeholders. Because one issue is it goes across like 9 different government departments. There's a whole bunch of different lobby groups on behalf, because if you are in renewable fuels, for example, you tend to have a different one than if you're in precision fermentation. And if you're sort of doing plants and crops, it's sort of different again. So given the breadth of product availability, which is actually more difficult than almost any other industry I can think of to coordinate, it's actually like really impressive on the one hand. But from where I sit, it's not that the industry is not talking to each other. It's sort of like there's been like really detailed plans published, including by Rob's team, like a really good plan on synthetic biology. Where I think we do sort of miss is we need somehow to get scale-up facilities in the ground in a coordinated way soon. That's where I sit. If we don't do that, we are going to have companies that are sort of sitting and waiting and not able to, prove themselves at a scale-up facility level, and then they just either die on the vine or they go elsewhere, or they get to market too slowly. That's the real risk, because once again, I spent a lot of time looking at China, and the time from lab to scale up now in China has shrunk significantly compared to where it was, 3 or 4 or 5 years ago. And they are looking at direct competitor products to things that we're doing here. So we're actually in a good spot. We have a huge foundational base. The government is doing way better than before across all technologies for manufacturing. But I think we've actually got to go an extra step now and get that coordination right. It's actually not a huge amount of money compared to what's being offered across all of like the Future Made in Australia policy, and then all the subsections and all the state government. The money itself is not big, but it needs to come quickly and it needs to be coordinated, and it probably the structures aren't quite working for it right there. All right, rant over. Thank you, Rob. Thank you, Michelle. And thank you to everyone online. Also my co-authors, Dan Santos and Dan Pavlich, who are at the ANU as well. And Justin, the editor, is online today as well. Thank you for this. Really, really appreciate it. And hopefully we can, have some more biomanufactured products coming out soon. Love a good rant to finish. Thanks, Tom. All right, we'll finish up there, and everyone have a great day. Thank you.